So we're moving on with Mihailo Joksimovic, Senior Software Engineer at Microsoft, who is going to talk about containers for data scientists in a hurry. He'll save you some time and share the meaty parts.
Thank you. Whoopa. Thank you. All right. Yeah, I have to scare you a bit first. I'm not a data scientist, and my job has nothing to do with data science. Right? Now, if you want to leave and take a break, now would be the perfect time. All right. So yeah, I'm actually building databases. You know, like I'm working as a senior engineer. I'm wrangling bits, as I like to say, but not much with data science. Oof. Right. But if you stay, I actually promise you that you will enjoy and you will learn and you will, you know, like live fulfilled for this long-awaited coffee break. All right. So I hope you decide to stay. Right. If you ever attended my presentations in the past, you might know that, if not, you will learn now, obviously, that I love to open up with some horror story, all right? Now this was just to frustrate you a bit. Now the real horror comes, all right? And what I usually open up is with a story of how I became a father and sleepless nights and, you know, all the struggle and yada, 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 and people were like, freaking out and whatnot. But that changed, obviously, so that's not a horror anymore. It's quite pleasant now. So I have a better horror story, which probably fits better the conference, all right? So I'm blogging actively as well, and I kind of got into all the craze about Midjourney, AI, and all the things. And basically, I figured, wow, I really suck at creating images, but I figured out that Midjourney can actually, you know, like you give it a prompt. If you never used it, it's awesome. Like you give it a prompt, you describe what you want, it generates an image for you, all right? So I kind of started creating all kinds of complex images, you know, like karate avocado and stuff like that, which actually worked perfectly fine. And then I came to a point when I was trying to describe a frustrated writer who is at the verge of burnout, he's freaking out, and he's typing on a typewriter, all right? And no matter what I tried, I just couldn't get a freaking typewriter to be turned towards the writer, you know? It just kept generating this typewriter facing the camera, all right? And what I figured out is that at some point, you know, you can learn to use stuff. You can learn to, you know, like how to do data science or how to apply ChatGPT to programming or whatnot. But there comes a point in time where you actually really need to understand the matter, all right? And if you don't understand the matter, well, you either go to an expert who does, or you actually go and learn about the matter. So what I want to show you here is, because I'm pretty sure that most people are usually familiar with containers and whatnot, but not many people really realize what they are and how they work under the hood and get frustrated, you know, over the time. So, yeah, for starters, no progress without the knowledge of the basics, right? So I'll give you the basics, and the thing is, once you actually learn these basics, you will be capable of doing a lot, as you will see, all right? Now, basically, for starters, like, what are the containers and why do we do it at all and stuff like that, all right? Because, as I said, many people actually have an idea, but I don't think it's not that clear. And basically, when I said in the description the meaty parts are because I was the one who was using them without actually having an idea how they work, all right? And I usually kept saying some things which you will see as soon, but once it gets to actually understanding them, it was a bit of a challenge, all right? So the whole idea with containerization or whatever is basically how do we actually reproduce what we have on our local computer, like be it an ML workflow or an application that you've built, an API, whatever. How do you actually transfer it to production or to another person, right? Because that's usually a problem. It usually works on your machine, but the moment you actually switch a single bit, something goes wrong, right? And what do you have as an option? Well, you have an option to actually write a README file and, you know, like send it along, commit it, whatever, and expect the person would actually be able to reproduce what you did, right? Usually never works, all right? Another option is to actually take your whole system, all right? Like you can pretty much take the whole operating system, like bundle it into a file, like take your application, take its dependencies, take the, I don't know, Windows or Linux, whatever, pack it inside a huge, gigantic file and ship it as a virtual machine. And basically that actually ensures the reproducibility because you pretty much, you ship everything that is software related. The only part that is left is the hardware. Or you actually have containers, which are a bit more, lightweight way to do it, right? So the whole idea, well, one of the things, there are many other things which are not that clear, but one of the things of containers is to ensure that you can easily actually distribute the files. And there is actually a definition from something called OCI, which we will get to, which actually says that the containers should be a basic unit of software deliverability, deployability, whatever you want, all right? Basically, the container should be a basic unit of, this is my application, and application can be anything, all right? Like whatever you built that you actually want to send to production or to somebody else, or maybe to move to your other laptop, that's an application, all right? Now, when it comes to, when it comes to containers and everything, so many people have heard about Docker, all right? I'm pretty sure that most of you are familiar, and Docker is containers and whatnot. This is exactly what I thought, and one of the things that kind of blew my mind was when I realized that Docker is not containers, all right? Docker is just one of the ways to do containers, all right? Granted, it's the most popular way of doing containers, definitely, but is it the only one? Absolutely not, all right? So if you ever heard of something called CNCF Landscape, it's basically a website like a Cloud Native Computing Foundation that tries to collect and organize every possible solution that exists in the cloud native world, And basically they have like tons of stuff, don't even bother trying to understand. It's the point of this image is that there's a lot, all right? And there is this specific section over here which actually says container runtimes, all right? And if we zoom into that, we see that there is like quite a few container runtimes, and the runtime is actually what allows us to run the container, all right? Now, what you don't see here is Docker, all right? So why the hell is Docker not here? Now, the thing is that Docker is actually much more than just containerization solution. Docker is, as my favorite author on containers says, it's like a huge behemoth, It's a crazy, huge, complex thing that contains a bunch of things. One of the things is the actual runtime, but there is a lot more to it. And actually, Docker is one of the solutions that made it easy to use containers, all right? They just made it simple. It really is simple in comparison to some other things, but it's not the only one. And something that actually came out of Docker is the Containerd, all right? Containerd is basically a solution pretty much open sourced by Docker that's actually used by, I don't know, like pretty much everybody who doesn't want to use the whole Docker setup, all right? There's others, obviously Firecracker. I think if you ever looked into AWS Lambdas or whatnot, Firecracker is basically like a micro VM, and there are many others, all right, with some own benefits and challenges. Now, another thing, this is really funny actually. Once you actually decide that, yes, I want to actually learn the containers and I want to understand them and whatnot, and you start searching around, obviously, because that's what you do. It's not there are books, at least not the ones that I found that are actually useful. So you start searching around to try digging deeper into what containers are and whatnot. And one of the first things that you see is it says that containers are not a VM. All right, and that's probably something that whoever you ask would answer. Yeah, well, container is it's a lightweight VM, but it's not really a VM, but it's kind of acts like a VM, but is it a VM? Well, it's not a VM. Well, what the hell is it, right? So this is something that I actually honestly struggled with. Like if you ask me, I don't know, like a year ago, like what's the difference between container and a VM, I would be like, well, I don't know. I mean, like it's not a VM, that's what I know, but I have no freaking idea what it is. So basically, I found an answer, hopefully, and what I usually like to open it up, first I like to compare the two, all right? So if you think of both in terms of reproducibility of something, like basically being able to reproduce your application, whatever the application is, somewhere in the production or elsewhere, right? As I said, you have two options. You have the super bulky option where you can think of it as if you were going for a vacation, basically if you packed your whole closet with you, and took it with you, basically it would be perfect. You would have all your stuff with you, right? But it's bulky, it's huge, it's not really practical, so it's not really, it works great, it gives you the most flexibility, and you don't have to worry if like fear of missing out is definitely not present, but it's problematic because, well, it's bulky, all right? Containers are lightweight. It's like a backpack, you carry only what you need, and this is the essence of it. Containers only carry the dependencies and your application, all right? Now, we can discuss it because some people are like, well, why is there a Linux kernel or whatnot? We can get to that, all right? But in a nutshell, containers carry only the dependencies, and VM carries pretty much your whole closet, all right? Now, another thing that is not so known, which actually I found fascinating, is that container is really just an isolated process, all right? And what's actually even more funny is that the container has no idea that it's an isolated process. So if you start an application, like I don't know, like a workflow or anything, like a desktop application or whatever it is, if you start it inside a container, if it actually tried to see what's running on the system, it would see fully functional file system. If it's a Windows native containers, yes, Windows supports containers natively, by the way. If it's a Windows based container, it would see the registry, it would have no idea that it's actually containerized, all right? So whatever is running inside a container has no idea that it's actually containerized. It thinks that it's running on a host operating system or inside a VM. It thinks that it has everything, including file system, for itself. So that's actually great because you can do a lot of stuff. You can do a bunch of stuff inside your isolated environment without actually interfering with, for example, another environment. You can start a bunch of environments which can do a bunch of crazy stuff inside without mingling with the other environment, all right? So in a way, I like to say that containers are like the Truman Show, all right? They think they are independent. They think they are free. They think they have their whole world, their own will, whatever. But they aren't, all right? There is somebody watching them. There is somebody who is actually, who they are running inside, and that someone, I'm sorry, and that someone is actually the operating system that they are running on top. Now, this is the image that I can absolutely assure you I couldn't find elsewhere. If you find it anywhere, please let me know. But basically, this is the answer that you need to give to people who ask you, what's the difference between a VM and a container, all right? Like, I guarantee you that I might be the only one who actually drew this. You have a bunch of images which actually go into so many details, all right? And if you know the details, yeah, it's perfect, you understand it. But for somebody who had no clue, like, yeah, well, container is not a VM, but what it is, well, you can't find a simple and easy to digest material, right? So basically, the main difference between a VM and a container is that your VM will talk directly to the hardware through the virtualization, or through the hypervisor, actually, okay? So basically, from the VM, you don't even, like, you have your host operating system, and you have a VM on top of it, and the VM actually talks directly to the hardware, completely avoiding the operating system that's running on underneath it, all right? So it's super isolated, it's super secure, it's basically super efficient because it talks directly to the hardware. There is a small overhead because you have to virtualize stuff, all right? But basically, the VM talks directly to the hardware. When it comes to containers, they are lightweight because they don't have their own kernel, all right? They reuse your operating system's kernel. So basically, the container packages your application and the dependencies, but when it comes to actually interacting with kernel, which is pretty much you always eventually have to interact with kernel to do anything with the hardware, that's where they actually reuse the host operating system instead of talking directly to the hardware. And that's why they're lightweight, because starting an operating system is a costly operation, all right? Booting an operating system, booting up a kernel is what takes time, If you don't have to do it, well, it's lightweight. And that's why containers are generally lightweight, by the way. Now, there is this image that I won't bother you with. If you want to understand the details of how it architecturally works, this is the image. I also guarantee that there are no many places where you could find this, or any place, but basically, at the end of the presentation, I will actually share a link where you can find, I did like tons of infographics on this topic, and this is one topic that I really drilled into. So if you're interested in like inner details, and this is really funny to be honest, really interesting, you can find it at the end. One important thing, so many people think that Docker is specific to Linux. That's absolutely bullcrap, all right? Windows can run containers natively since like 2015, basically. You can build Windows applications, use the Windows as the base operating system. It works perfectly. It works just fine as on Linux. And what's even more important, we call them cows, containers on Windows. I have no idea why, but somebody figured out that a cow is a perfect name for a container on Windows. So if you're running Windows, don't be scared. You can containerize whatever you want, all right? Now, if you're like enthusiastic and whatnot, you eventually figure out, you figure out, okay, Docker is not a VM, whatnot. Then you come into the world of OCI. People start blogging and talking and whatnot about OCI specification, and you have no idea what OCI specification is. And what's even worse, if you go and open the OCI specification, good luck, honestly. It took me like a month and a half to actually try to understand what the hell they were trying to say, right? It's so confusingly written. Each damn diagram is so confusing that it's just mind-boggling, all right? And I really think this OCI specification thing was actually written for people who know what OCI specification is and just want to clarify things. If you're a newcomer, good luck, all right? Luckily, you're attending here, so I will actually tell you. Like, I will, like, give you the essence of it, the meaty parts. OCI stands for Open Container Initiative, all right? And the whole thing is that basically, as I told you, Docker was not the only solution. Containers were emerged somewhere around 2000s, actually. There were Linux containers, and Google tried their own solution and whatnot. And basically, there were a bunch of emerging solutions which all had their own ways of how they functioned, all right? Eventually, around 2015, actually, those people who were building, like different solutions, they actually sit together, they wrote a specification, and they wrote a standard, a unified way to run containers regardless of the container runtime that's underneath it. So either like be it a containerd or cryo or I don't know, whatever it is that there is there, you can basically just, as long as it follows the standard, you can use whichever solution fits you, all right? And this open container initiative is generally great because once you actually standardize the things, you can build, like you can build things on top of it, you can extend it and whatnot, all right? Now, three main things about OCI that you need to know about, there are more actually, but three most important ones and most interesting ones are basically the image specification, the runtime specification, and distribution specification. And we'll get to what it is, all right? Basically, honestly, if you're not so familiar, my honest suggestion is don't even try to understand it. Check the link at the end. That actually will take you through my infographic. And once you feel a bit more comfortable, then you can actually go to OCI specification and try to understand what's going on, all right? So what the hell is an image, right? It's something that, again, if you were using Docker or Docker containers, whatever, basically, you probably know that if you want to start a container, which now you know is just an isolated process, but it's just a process. It's not like, it's not a separate thing. It's a process on your operating system. So you probably know that if you want to start a container, you need an image, and an image is probably some kind of a specification of what you want to run, all right? So speaking of images, what the hell, why the hell image, right? That's something that I just couldn't get. And if you come from, well, if you actually dug deeper into software, you would see that there are a lot, like exe files are called images, and there are so many things that are called images. And I was actually wondering, why the hell image? What's the thing about the image? Turns out that the image was meant to represent that it's actually, like a frozen state of a thing that you can actually resume, all right? So that's why it's called an image, an exe image, a Docker image. So basically, you freeze your application. It's like if you were playing a game, you save it. It's an image. It represents something that's frozen and can be unfrozen. And basically, this unfreezing process is actually referred to as starting a container, all right? So if you want to start a container, we already now kind of understand that image is, frozen state of the application. So what do you need if you want to start a container, all right? Well, obviously you need an image, right? That's kind of obvious, right? What you need inside the image are basically the application and its dependencies, like, I don't know, the Jupyter Notebook, the Python, the TensorFlow, I don't know, whatever the hell you're using, all right? Basically, you pack the executable, you pack the dependencies, and whatever else do you need. And you need a way to actually tell the runtime how to run it. And funny thing is that I wasn't aware of, the image is just a file. It's like a tarball. It actually is a tarball, to be honest. And you can actually untar it, and you can see the content of the image. Content of the image is just, your files, some metadata, and whatnot, all right? Speaking of images, I just found a random one that, this is you probably have seen the Docker files. Now I'm realizing that people on the left-hand side probably can't see this, and I really apologize. I'll try to describe what's here. So basically, if you open a Docker file, you see a bunch of commands, and those bunch of commands actually, you can't see it. So this is kind of a bit of an unfortunate. I'll get to the essence, actually. So the whole point is that when you define a Docker file, and you have to understand, I already told you, Docker is just one of the ways of doing containers, and it's a simple way. They simplified it, all right? And they made these Docker files, which are actually a simple way of allowing you to, specify what they allow you to easily containerize your application in a human readable manner, all right? So these things that you see here are actually layers, all right? And now it sounds scary for somebody like who is not familiar, and what even gets people more scary is that when they receive the image, when they receive the error that image has to be rebuilt and whatnot, and you're like, what the hell? I was just supposed to pull, a Docker pull, Docker run, now it's asking me to build, whatever. So you can think of the layers as a cake, all right? So if you're trying to containerize the application, you are actually putting layers of dependencies on top. So the first layer would be a Windows operating system, or a super small Linux, super small footprint of a Linux, or if you really want to go super efficient, you can actually there are tools that extract only the specific dependencies that you need to start the container. So you usually start with something called base image. It can be empty, or it can be something predefined, all right? Then on top of that, you add dependencies like, I don't know, Python, TensorFlow, or whatever, like .NET. You add your dependencies. On top, you add your application, like something that you want to run, something that you are actually containerizing and that you want to distribute. And this is a fun part. When the runtime actually takes these dependencies, they actually kind of unionizes them, takes all the files, creates one flat file system as if it was, just one thing, and it puts a thin read-write layer on top of it. And this is really cool. Whatever you write inside a container will actually go to this thin layer, all right? And what's amusing is that actually basically just imagine modifying files, I don't know, removing the whole Linux kernel or whatever you want. Whatever you do, actually it gets persisted to this top layer, and when your container exits, this layer gets discarded, actually. So this is something that documentation says that containers are ephemeral, all right, which is quite a funny word for non-native English speakers like I am, but this pretty much means that whatever you do inside the container will actually get wiped out. And this is by design, basically, because it allows you to experiment with whatever you want, and if you mess up or make a bunch of crap, you can just discard it, start another container, or you can actually run multiple containers, one side by side, and they wouldn't interfere with whatever you're messing up, whatever you're doing inside this underlying system that's seen by the container. And this is something called union mount, by the way, if you want to actually take a deeper look. The union mount is basically the idea that you take the layers and you create a single layer, and it acts as if there weren't layers. Layers are awesome because if you use them smartly, you can actually make a really, really simple stuff. You can make really efficient stuff. Like, just imagine if you were developing, I don't know, 20 different workflows, right? Like, or models or whatever. And if 20 of them were based on the Linux kernel or something, and plus some Python, plus whatever, if you basically were using the VMs, you would have to ship all of that every time, right? When you have layers, layers can be cached, all right? And each layer gets cached either on your local system, and even some registries actually help you with it. So basically, when you use layers, if you use them smartly, like if only thing that changes is the top layer and only your app or some minor dependencies, it can actually reduce a lot of the boot times, distribution times, and basically it can save you a lot of storage, all right? So what you see here is I just pulled an ASP.NET image, and these things that you see here are actually the layers, all right? One is the Windows operating system, another one is, I don't know, the .NET framework and stuff like that, all right? And basically when you're rebuilding the image, you're actually just, what you take from the Docker file, you take those layers and you actually are packing them into an image. And what's even more cool is that there is like, I usually like to call it a GitHub for containers. There are the Docker registries where you can actually push your images, like you can build your workflow, and instead of providing a README file on how should somebody reproduce it, you can actually push it to a registry, you know, and basically every major cloud provider has one, including, I don't know, the Azure, the Elastic Container Registry, the Google, whatnot. You can even use your private solutions like I think Harbor or whatever. There are a bunch of solutions that allow you to host your containers, and they take care of caching and whatnot of layers. And whoever wants to use your application, like imagine that you want to deploy it to production, or you want to take it to, like you want to reproduce it on your colleague's computer, they can just pull from this registry, all right? So it's really cool. So in a nutshell, and to kind of summarize, if you're wondering why containers, well, for one, they are basically cloud-friendly because they're efficient, they are small, they are stateless by nature, all right, all of the things that are kind of favored when it comes to cloud. They provide isolation, and this is actually something that I'm spending a lot of my time doing because isolation is something that we really care in terms of the team, the security team that I'm working with. We really care a lot about process isolation, and containers are one way that provide you this. There are other ways which are actually quite interesting, but we can discuss them separately. Distribution or works on my computer shouldn't be an issue anymore because you pretty much pack, well, you pack what you need and you send it to your colleague, all right? So the distribution shouldn't be a problem anymore. And finally, you know, like Kubernetes and all kinds of crazy things that scare people are actually made to work perfectly with containers. So that's actually almost about it. If you want to learn more, you can find my huge infographic which digs deep into containers, basically. So it's bite-sized containers, and this is just some URL shortener. So you can find the deep version of this there, and once you actually go through it, if you want, you can obviously check the OCI specification and then try to understand it. And yeah, I'm actually a bit ahead of time. So thank you very much. It was a pleasure. I'll take questions now. You can find my blog here where I blog a lot about SQL Server, containers, C++, C#, all kinds of crazy things. You can connect with me on LinkedIn. And by the way, this is I, not Y. I don't know why people think it's bite-sized. No, it's like a bite. I chewed it for you, and I actually delivered it for you to digest it easily, just like this presentation. So thank you very much, and I'm happy to take any questions.